Okay, so we're going to go over 7.1, which is introducing us to Chapter 7. Chapter 7 is all about similar figures. So we've talked a lot about congruent figures, mainly congruent triangles. Now we're going to talk about similar. So a ratio is a quotient when one number is divided by a second. Both numbers must have the same unit. So if you're looking at a ratio of measurements, they should be inches to inches or feet to feet. You can convert them if they're not. A proportion is an equation stating that two ratios are equal. The ratios do not need to have the same units in order to do this. That kind of sounds like it's contradicting itself. Usually when they're different units, it's called a rate versus a ratio. So a proportion is kind of just saying that two fractions are equal to each other. For example, okay, if we say something like 1/2 equals 2/4. Okay, just trying to get this set. Sorry, guys. Okay, that's a proportion. It's stating that two things are equal. So sometimes you'll see a proportion with a missing part. Remember that they have to represent the same thing. They have to be equal. So you can do the cross multiplication. We're going to talk about some of those actually tomorrow. So find the ratio of AE to BE. These are the really easy problems. Remember, it's section 1. So AE is 10, BE is 5x. So you can write it as a fraction or with the 2 dots. The 2 dots are just like a fraction bar. So this can be reduced back to 2x. Okay? So that's the answer you would put down, the reduced one. Find the ratio of the largest angle of triangle ACE to the smallest angle of triangle DBE. Okay, well, 60 and 30 means that this must be 90. And by VAT, these are 90. Now remember, just to clear up something we were talking about in the previous chapter, although these have the same angles, they don't have to be congruent. I can make a teeny tiny triangle that has angles 30, 60, 90, and I could make a triangle as big as the school with 30, 60, 90 triangles. So the largest angle of triangle ACE is 90. And the smallest angle of triangle DBE is 30. So the ratio, the reduced ratio, would be 3 to 1. Okay, not too hard. A rectangular field has a length of 1 kilometer and a width of 300 meters. What you need to be careful here is this is meters, this is kilometers, and in a ratio we want them to be the same length. So 1 kilometer is 1,000 meters. You could also do this the other way, changing 300 meters to kilometers. So I'm going to change the 1 kilometer to 1,000 meters. Now I have them with the same unit, meters to meters. So my reduced ratio would be 10 to 3. I'm getting pretty good at writing on this. All right, a telephone pole 7 meters tall snaps into 2 parts during a windstorm. The ratio of the parts is 3 to 2. Now, you did problems like this last year in Algebra 1. Okay. Now, they're in the ratio of 3 to 2, which obviously means they're not 3 and 2 because that would only equal 5. But what that means is the ratio of this part to this part has to reduce down to 3 to 2. So in order for them to reduce, you would have to divide them by the same number. So we would be multiplying them by the same number. So I know that 3x plus 2x has to equal the whole length of 7. Okay, you can solve that. And I get x equals 1.4. Now that's not the length of the part, that's that common multiplier. It's when it reduced back to 3 to 2, it means that it divided both parts by 1.4. So to get the length of each part, you're just going to take the 3 and multiply that by 1.4. So that gives you 4.2. And take the 2, multiply it by 1.4. That's 2.8. So the lengths of the 2 were 4.2 meters and 2.8 meters. Over here, this is pretty easy. 2 to 3. In this one, you could reduce the numbers and the variables. You could reduce this down to x to 2y using algebra. And then you could plug in what you have. So the x is 2, the y is 3. So 2 times 3 makes this 6. Gives me my final answer of 1 to 3. And the last one, y minus x over x, gives me a 1/2 ratio. Okay, so that's just using some algebra. Okay, over here, again, it's a similar idea. This is A, because you have the 6 and the 12 cancel to be 2. And a B and a C. Over here, you're going to need to factor out that denominator first. Remember, you cancel factors, not terms. If you're not sure what I mean by that, you can ask in class. A term is something that's added. So the first thing you need to do here is factor out. And you went over this with Mr. Lewis last year. Then I have factors now, so I can cancel out the a minus b's. And that gives me 2 over 3. For the last, this one's going to work kind of like the telephone problem. Again, it reduces back to 7 to 8. So 7x plus 8x equals complementary, means they equal 90. 15x equals 90. So x equals 6. Just double check my math on that one. Okay. Now that's not the measure of each angle. To get the measure of each angle, I'm going to do 7 times 6. That's 42. And I'm going to do 8 times 6, because the 6 is what I reduced by, and that's 48. So the measure of each angle was 42 and 48. They reduce back to a 7 to 8 ratio if you took those and reduced that fraction, and they add to be 90. Okay, so that ends our just beginning 7-1. And we're going to talk about this and look at this more tomorrow in class. So make sure your notes are filled in.